Assalamualaikum and selamat sejahtera. Which slide? We stop.
Waalaikumsalam, Doctor.
Slide number. Slide number. Stop mana? Anybody please help? Slide number. Stop. Kat mana? Yeah. 65. Okay. So we move to example 66 by considering the example shown here, 66. So you are given an open loop transfer functions, g j omega, 1 over j omega, 1 plus j omega, 1 plus j omega 0.5. Or in S is call it as 1 over okay. So S is equal to j omega, right? So determine the gain margin, phase margin, omega GM, omega PM, and stability on the open loop load, then the MP, omega P, and bandwidth on the closed loop. So plot is given, you don't have to plot, okay? Plot is given, so from the plot, we find the frequency omega GM, where the magnitude cut at minus 180 degrees, which is here. Okay. Then goes up at 1.42 radian per second. So the magnitude value is minus 9.54 decibel. So therefore the gain margin is 0 minus 9.54 is positive 9.54 decibels for the gain margin. And for the phase margin, look at the frequency where the magnitude cut at 0 decibel, which over there. So it is omega PM. So omega phase margin frequency is 0.749, go down. And then look at the phase. So the phase over there is 100 and berapa tu? Yeah. Okay. It's about 135 something. Okay. 135 something is, we use the calculator. 180 minus 32.6. 147.4. So over here is minus 147.4 degree. Okay. And then the phase margin will be minus 147.4 minus 180 degrees. So it will be 32.6 degrees. Okay, phase margin, positive. So positive and gain margin, positive phase margin, that is the indicator that the system is stable. Okay. Then how we get T? How we get closed loop? E j omega. E j omega is G j omega 1 plus G j omega. Okay. So we get this closed loop transfer function, then we plot, right? Then we get the given workload in magnitude and phase versus frequency. And from here, we obtain three important information. which is the MP, omega P, and omega bandwidth. So let's go to the peak magnitude. So the peak gain is 5.28 decibel here. But the MP is not in decibel. So 20 log MP equal to 5.28 decibels. So using anti-log, 10 power of 5.28 divided by 20, 1.8365. Okay, so this value is very important because we are going to insert this value to the formula in order to find the corresponding zeta. The omega P is 0.824, which is the, we call it as the resonant frequency. Everybody follow me. Resonant frequency.
Resonant frequency.
Seorang je. Resonant frequency.
Resonant
Frequency.
Kan tidur ke? I thought you're sleeping. Okay, so resonant frequency is the frequency that is correspond to the peak gain. Then omega bandwidth is at -3 decibel. So you find -3 decibel on the left-hand scale. Use your ruler and cut the magnitude curve. So the frequency I go down and the frequency is 1.26 radian per second. Any question for this? Clear? Clear, guys? Hello? Clear?
Clear, bro.
Right, next example is this one. GS is equal to 5 over S, 1 plus 0.6S multiplied by 1 plus 0.1S. Again, same question, but you have to find the approximate zeta and omega n. Okay, right. So given the bow plot, again, find the omega gain margin. Omega gain margin at phase cut minus 180 degrees. Okay. Then the value is 4.13 and then goes to the magnitude plot. 4.13 is about here. Okay, so the gain margin is minus 7.36. So gain margin is 0 minus positive 7.36. Phase margin also the same. Find the curve where it cut 0 decibel. Is omega PM, omega phase margin. Then we go down at frequency 2.61. Sorry, 2.61. So the phase is 162, which is over here. 162 degrees. Okay, so 162 degrees will give the phase margin minus 162 minus 180. So 18 degree. Betul? Si Micin, betul?
Betul.
Sepak degree. Sepak degree. Then system is stable. Goes to the closed loop again. So closed loop is J omega 1 plus J omega. So we'll give this plot. Plot is given. You don't have to plot. So the peak gain is at 10.3 decibel. MP is 3.2734. And resonant frequency is 2.71 and bandwidth at -3 decibel 4.16. So for damping ratio, this is the formula for damping ratio, which is MP equal to 1 over 2 zeta square root 1 minus zeta square equal to 3.2734. So how to find the zeta? Okay, 1 minus zeta square is equal to berapa? Cuba kira. Square 0.5. 42.86 zeta square. Okay. Pula. Okay, equal to 1. Or 1 over 0.023. So what is the roots? Chongjuan, what is the roots? Your calculator white color or black color?
White color.
White color. Eh? So white color can find roots of 4 roots.
No
Can-
way. Until 3 nya.
Huh?
Until 3 only.
Oh, yang putih boleh sampai 4. White calculator can find 4 roots. So how to find the roots of zeta power of 4? Chongjuan?
Use my lab.
Huh? Use MATLAB. So okay. Roots. Okay, so we have 4 values. Negative. Negative is negative is ignored. So choose zeta 0.1 153 15 as the value because 0.98 the critical, damn critical. Okay, and then use 0.15 value. Okay, so this one is 2.71, zeta 0.15. So find omega n. What is the value of omega n? Berapa? Divergent? 2.71 divided by square root 1 minus 2 multiplied by 0.15 square. Divergent? Tak ada.
2.77.
2.77
77.
radian per second. Okay, itu cara dia. Right. Okay, and then next example about the same. Okay, yang ini.
Betul.
Yep, saya.
Tadi tu saya kurang faham pasal critical dam. Kenapa pilih? Kan
Pilih empat value.
kosong value tu saya kurang.
Value. Satu is 0.98. Satu lagi negatif. Satu lagi 4.
Okay.
Negatif tak ambil. Negatif
Hmm.
damping tak ambil. 0.98 critical ni. Damping critical tak ambil. Which is equal to 1. So we choose 0.15 lah. Under dam.
Kenapa kita tak boleh ambil critical dam? Sebab dia kesemua ada kaitan dengan equation tu. Kena ambil ada dam benda tu.
So dam dia ada undam, critical dam dengan under dam. So the best operational of control system must be in the region of under dam, which is between 0 to 1. 0 undam, 1 critical dam. The problem with the student, they assume critical dam is equal to critical gain. That is the typical mistakes made by the student. Critical zeta is not the same with the critical gain. Student said it's the same, but it's not the same. Damping critical and critical gain is not the same. It's two different things. Okay. Did I answer your question, Irfan?
Terima kasih Dr.
Okay, all right. So next one is this one. So you have a GS. Okay. Okay, GS. $50. 1 plus 0.05s multiplied by 1 plus 2.5s. Question: what is the corner or break frequencies from the transfer function? Ahmad Faleh. What is the corner frequency? Ada dua corner frequency. Tak tahu. One, Muhammad Alimin.
Dia pergi ke toilet Dr.
Pergi toilet. Bang Jin. Bang Jin, what is the value of the first corner frequency? Bang Jin dah datang eh?
For me,
Ah,
0.05 radian per second.
sorry?
0.05 radian per second.
0.05 radian per second.
Bukan kan?
Salah
Hah?
Salah. Simichin, what is the first break frequency?
20.
How you get 20?
1 per 0.05 get 20.
Correct. Frequency corner 1. 1 over 0.05, 20 radian per second. Wengjin, again. Frequency corner 2.
Wait lah.
Wait ah.
0.4.
0.4 radian per second. Okay. So that is how you calculate the corner frequency, 1 over 0.05 and 1 over 2.5. Then plot is given. Okay, plot is given as shown here. So how to find omega GM from this plot? Fikri, how to find omega GM from this plot?
By looking at the graph.
Memanglah looking at the graph. How to find omega GM? When
Omega GM equal to 1000.
phase curve cut at minus 180 degrees. Niha.
Thank you, Prof.
Okay, sekali lagi, omega phase margin. Macam mana nak cari omega phase margin? When gain curve cut at Fikri, cut at
negative 180 degree.
Astaghfirullah, cut at 0
0
dB. Aduh, kepala aja budak-budak. Tolong ingat, okay, cut at 0 dB, tak fokus ni. Aduh. Okay, gain margin 68, phase margin 53.3, system stable. Then close loop is here. Okay, peak is 1.01, MP is anti-lock 1.1233, resonant frequency 14.8, and bandwidth at minus 3 decibel, 25.2 radian per second. And from the MP value, magnitude peak 1.1233, insert here, then calculate as I show you before. Okay. Then you choose 0.513. This is under dam. Okay. Then omega n is 22 radian per second. Can you see the empty space here? Can you see the empty space? Amir Zafran?
Yes, Doctor.
Can you see the empty space here?
Yes.
So fill up with the solutions. How you calculate zeta and omega n. Okay? Okay? Okay?
Okay, Doctor.
Amir Zafran buat, nanti snapshot hantar pada saya after class. I want to see the solution. Boleh?
Boleh, Doctor.
InsyaAllah boleh.
InsyaAllah. Solution tak apa, Doctor? Ulang boleh?
Astaghfirullahalazim. Slide 76. Slide 76
okay.
empty. Solution to calculate zeta and omega n.
Oh, Zeta omega n. Boleh, Doctor.
Bersorang je. Screenshot. Okay. Okay. Next is this one, exercise lagi. So why my notes have a lot of exercise? Because the previous student from the previous session give a feedback, not enough example, not enough past year discussion, past year test, and so on. So I blended everything in one. Okay. Okay. Next question. Safwana. Corner frequency. F1.
Wait
Wait,
first 5 radian per second,
macam mana dapat?
1/0.2.
Okay.
Next one is 50 radian per second,
How you get?
1/0.02.
Thank you very much. Frequency done. Gain margin and phase margin. Sekali lagi Fikri. Fikri. Oh, Fikri. Mana Fikri? Tak ada. Patrick, how you get omega GM from the plot?
Omega GM from the plot. Just look at the gain margin there.
Oh, how you get omega GM?
Omega GM. Omega GM I get from the when I put phase graph to -180.
Omega PM, phase margin?
When magnitude equal to 0 dB.
When the magnitude cut the 0 decibel point. Then from here we get gain margin 14.8 and phase margin 31.7. Both are positive. So system is stable, and then magnitude peak and is shown here. Okay. So which is magnitude peak is 8. Okay, how do I get 8? MP, how do I get 8? Sharizal, how do I get 8 in MP ni? Shahrizal? Tak datang? Tak datang. Mukri?
Mukri pergi tandas, Prof.
Mukri pergi tandas.
Yes.
Ahmad Tariq, Amjad Tariq. How do I get 8 here? Amjad.
Yes, doctor.
When I call you,
How we get 8?
how do I get 8 here? Magnitude peak.
The magnitude at 0 dB, is it?
Astaghfirullah al-azim. Don't understand again. Felix.
Yes, dokter.
Kamu di mana, Pak?
Ya, dokter.
Kamu di mana?
Baru sampai Malaysia.
Baru sampai Malaysia.
Iya.
Ya, kamu di mana sekarang?
KLG.
KLG. Oke lah, kamu rehat dulu. Saya tanya orang lain.
Thank you, dokter.
Firdaus, Muhammad Firdaus. Muhammad Firdaus, how do you get 8 there? Tak datang. Patrick, how do I get 8 SMP? Patrick absent. Sedap dia kelas online Patrick. How do I get 8? Absent. Chong Hoi Ki. $20. 5.28. Berapa?
1.84.
8. Apa nak? Betul.
Prof, the answer is 1.84 something.
1.84. Itulah saya tanya. Salah ni. 1.84. Okay, betulkan notes. 1.84. Okay, then find the zeta. And then find the omega.
Doctor, can you go to the previous slide?
This one. 20 log MP equal to 5.28. MP using anti-log. 10 power of 5.28 divided by 20, 1.84. Boleh?
Okay, Doctor, dah.
Ha?
Betul.
Siapa tu tadi? Ni. Oh ni.
Yes, Prof.
Demo kira zeta ni dengan omega n. Buat
Okay.
atas. Dan snapshot hantar pada saya WhatsApp
Baik.
after the class. Respond
Okay.
Alright, and then
Betul, can I ask the previous slide?
okay, ni
Yang tadi, lagi tu.
lagi satu. This one.
Just now you say cut to 0, I not little bit understand.
Omega PM, omega phase margin when the gain curve cut at 0 decibel. Ni 0.
Okay.
Nampak?
Nampak.
Sini dia potong. Frekuensi dia apa? Apa frekuensi dia?
50 point.
Ni frekuensi dia.
Boleh. Tu.
Apa?
6.1. Okay.
Apa dia? Unit.
Radian per second.
Radian per second. Lepas tu turun bawah. Tengok dekat phase. 6.21 radian per second. Ni kan? Ni 6.21 radian per second kan? What is the value of the phase? What is the value of the phase?
Doctor, why you cut from them? Because you say negative is cut from 180, right?
0 decibel. When the gain curve cut at 0 decibel. Ini dB. This is dB. This is degree.
Betul. Why cut potong kat situ. Bukan Doctor cakap negatif 80.
Tak faham apa cakap.
Nak ada tadi Doctor cakap cut negatif 180.
Tu nanti dulu. Ni dulu. Omega PM dulu. Satu-satu. One by one. So apa nilai dia? Phase-nya.
31.7.
Ni. Itu phase margin. Phase value-nya berapa? Ni 148 ni. Baca.
148.3.
Jadi phase margin is minus 148.3 minus 180 degrees. Berapa? 31.7 degree. Positif. Betul?
Betul.
Ni. Okay. Yang kedua is how you get omega GM. Omega GM, omega gain margin is when the phase cross at minus 180. Ni potong sini. Berapa frekuensi dia?
15.7.
Unit?
Radian per second.
Radian per second. Lepas tu go up. Tengok dekat gain. 15.7. Lebih kurang kat sini lah. Lebih kurang kat sini. 15.7. So what is the value of the gain over there? Minus 14.8 decibel. So that's why gain margin is 0 minus 14.8 positive 14.8 decibel. Okay. So in this topic, chapter 3, you must print out lah. Better this note you print out so that you can see. Okay, hard copy because they're using a graphical approach. Okay, so we move to the omega bandwidth. Okay, we have 3 formula. Do not memorize. It's been given in the attachment. One is with omega n. The other one is using a settling time. The other one is using a peak time. Okay, and also this one is the omega bandwidth and the time response specification versus damping ratio. This is also a standard graph that will be attached, okay, to the system. Okay, if you know the TS, if you know the damping ratio, so you just go to the graph 0.3, for example, damping ratio. Okay, so omega BTS equal to the damping ratio over there, and then you will get the value of the bandwidth. And this one is the omega bandwidth versus omega bandwidth TP versus zeta graph. Okay. My question is, what is the equation, curve equation for this? Chong Juan? What is the equation for this curve? Chong Juan tak datang?
Ya, ada datang.
Kat mana nama tak panggil? Kalau tak bunyi tak datang. What is the curve equation for this graph?
Pi over.
Huh?
Using the bandwidth equation.
Okay. Using the bandwidth equation, which is this one. Yeah. Okay. This is the equation. Okay. Liana Camelia.
Yes, Prof.
Tidur ke?
Tak lah.
What is the equation for this curve? Yes, this one. Okay. That is
Okay.
Nama no, coba. Dia depan mata tu. Okay. And this one is the omega bandwidth TR versus zeta graph, but TR equation is not here. I think it's in the book. Okay, there's one more for TR. Okay, so refer to nice BC. What is BC? What is BC, Jason? Huh? Refer to nice BC. What is BC?
Book. Oh, book chapter.
Chapter mah.
Yeah.
Chapter dalam WhatsApp tu tak tengok ke? Yo, tak baca lah tu. Jadi perhiasan. Okay.
Prof,
Yeah.
what is TR stands for?
Sorry.
What is TR stands for?
Mana? Ni. Ni.
Yeah, TR.
Cuba baca.
Rising time. Okay.
Cuba baca. Cuba baca.
Rising time.
What is rising time? Terlanjur dah tanya tu.
Tu.
Balik. Fikri ya?
Rising time.
Rising time. What is the definition of rising time?
Rising time masa untuk sampai
English, because we have Arab students.
time
Time taken
to reach
for the time taken for the student
for the
to wake up from sleeping. Astaghfirullahalazim. T 90% minus T 10%. Okay. Of final value. And so that is the rising time. Okay. So biasalah student lupa. Apa yang dia ingat? Dia ingat makan je. Makan. Tengok sini. This is time response. Okay. And then this is the response. So kita ambil sini T 10%, sini T 90%. Okay. So the distance is rising time. T 90 minus T 10. Understand? Faham tak? Agree?
faham betul.
Okay, take note. So next example is page 84. Find the closed loop bandwidth required for 20% overshoot and 2 second settling time. Okay, settling time is where the time settle at plus minus 2% of final value. So 20% kita, what is the equivalent of 20%? What is the equivalent zeta value? Atika? What is the equivalent zeta value for 20% overshoot?
0.456.
0.456. How do you get?
4 million.
From the graph. Okay. From the graph, standard graph. From the formula also can. From the overshoot formula also can. So ada three method to find 0.456, which is correspond to 20% overshoot. So settling time 2 seconds, insert the value, insert the zeta, then you will get the bandwidth at 5.79 radian per second. Very straightforward. Example 5 is given a unity feedback system with the GS K S plus 1 S plus 2. Okay, so system type 1, third order. Why the system is type 1?
Because S power of 1.
Because S power of 1, single pole at the origin. Why the system is third order? Daniel Imtiaz. Why the system is third order? Why the system is third order? Tak faham. Tak faham. Zulhelmi, why the system is third order? Tak faham. Tak tahu. Yuki Wong?
Yes, doctor, because by looking at the characteristic equation, when time O equal to 1, then it will be 3 S power to 3.
Because the highest order of denominator is 3. S power of S square multiplied by S cubic. Okay. So that's why dia adalah third order. So, isu apa ni? Find the system gain margin and phase margin, maximum amplitude and bandwidth for K equal to 1 and K equal to 10. Okay, and then kita buat macam ni lah. Table, okay. Right, K equal to 1, open loop. So this is the open loop. So gain margin 15.6 and phase margin is 53.4. Dia bagi value positive, system stable. Okay. Ismail. Syekh. Datang. Ivan.
Yes, doctor.
What is the value of omega gain margin?
1.41.
Radian per second. What is the value of omega phase margin?
0.446.
Very good. Okay. So actually, she read from here lah. 1.1.
Actually is the second studio album by English synth pop duo Pet Shop Boys, released on the 7th of
Ciao Siri. 2.09. System stable. Okay. And then close loop for K equal to 1. Okay. So we observe there is a peak gain 0.9 to 1 and resonant frequency 0.54 radian per second. And then the bandwidth at minus 3 decibel is 0.793. Okay. So what is the value of MP? Magnitude peak. Mukri.
Uh, 10 power of the peak value over 10 over 20.
Over
20.
berapa?
I got 1.11.
1.11. Okay, thank you. Okay. 10 change to 10. K equal to 10. So K equal to 1 is stable. Then K equal to 10. Your observation, Mukri. First is what is the omega GM?
Yes, sir.
Omega GM.
Omega GM 1.41 radian per second. Omega PM 1.8 radian per second.
So your observation of the system stability status?
Stable.
Astaghfirullah al-azim.
Unstable. Sorry.
Unstable. Okay. Yes.
Doktor, saya keliru dengan yang tadi tu dengan yang ni. Dia kan positif kan stable. Yang ni pun positif kenapa? Tu saya kurang. Yang mana yang positif? Nak doktor clearkan.
Gain margin ni berapa, Irfan?
Oh, negatif. Okay, faham. Tapi dekat tu, dekat aplikasi dia.
Irfan ni tak print lah. Print lah. Ni nampak.
Okay.
Tak nampak Nampak tak nampak?
Nampak.
Jauh Irfan. Okay, unstable. Okay. Tak apa, belajar. Tak apa. Jangan pandang belakang. Salah, baiki. Betul kan? Close loop. Jason, what is the value of MP? Wait. Apa? Lamanya.
Yeah.
14 divided by 20 mah.
Yeah, because I find my calculator.
Oh,
5 dB. 5 dB.
5 dB.
5 dB.
Si Micin, verify please. Betul tak?
Ya, betul.
Toy ya, toy. Right. So what happened? We changed there from k equal to 1 to k equal to 10, and then finally changed to k equal to 6. What happened? Okay, and the plot is shown here. Natra, what is your observation?
The system,
English. Natra,
margin is
English.
stable.
Huh?
Margin is stable.
Why?
Because gain margin is 0. This margin 0.
0 what?
0 degree.
Then? Some more?
Omega cm
Equal to omega PM equal to
1.41
unit.
radian per second.
Very good. Okay. Mana tu? Ada di sini lah. Dibaca kat sini. Then kita tengok plot ya. So this is the plot, both plot when the system is critical. Si Micin, can you give a few words on this plot? Your observation, your suggestion, your opinion. Hah? Jangan ketawa.
Tak tahu nak cakap apa.
Tak nak cakap apa. Tika, bagi sikit sepatah dua kata. So this is the response, the frequency response when the system is marginal stable or critical stable, okay? Where the gain give a very sharp peak at 150 decibel. Okay, and the phase is below minus 180 degrees. And the sharp change at the what? At the corner frequency, kan? Corner frequency is about 1.5 radian per second. Okay lah, boleh lah. Daripada tak ada apa nak cakap. Okay. Okay guys, we have a break for 10 minutes. Is it okay? 10 minutes break?
Okay.
Okay guys, we continue on the slide number 99. Can you hear me? Can you hear me?
Yes, bro.
So alternative way to represent the frequency response is using a Nichols chart. We have a both plot. Then the alternative way is Nichols chart. But both plot have the drawbacks because
You're not sharing your screen?
oh sorry. Sorry. Slide 99. So we have two ways to plot frequency response data. The first one is a both plot, and the second one is Nichols chart. So what is the difference? The difference is both plot show open loop and closed loop in different graph. Okay, but Nichols chart, both open loop and closed loop together in one graph. Okay, so that is the difference between both plot and Nichols chart. But for the scope of the subjects, the coordinator said just inform the student the alternative way, Nichols chart. Nichols chart will not goes to the test 2 and final exam, will not be asked in final exam and Nichols chart. Okay, just to inform you that Nichols chart is the alternative way to plot frequency response data and to observe informations same as the gain margin, phase margin, stability, MP, resonant frequency, and the bandwidth of -3 decibels. Okay, so we can skip this one. Okay, just to inform you, that's all. So the relationships between the Nichols chart and both plot is that Nichols chart have the ability to show the data in one graph, the open loop informations and the closed loop informations. And from these relations, we can create a damping ratio and phase margin relationship, which is given by this formula. Phase margin equal to inverse tangent 2 zeta square root 1 minus 2 zeta square plus square root 1 plus 4 zeta power of 4. Do not memorize this formula. This formula is given in the test 2 attachment and final exam attachment. Okay. So what is the equation of this curve? Ivan, what is the equation for this curve?
Inverse tangent
2 zeta over square
2
root
zeta. Yeah.
Okay. So you will give either this formula or if the formula is not given, so they will give you the graph. Okay, the standard graph. So just see if phase margin is 50, what is the corresponding zeta? That's all. Okay. Right. From the both plot, we can get the steady state error from the frequency response by considering this formula. Steady state error is equal to limit S to 0, SRS over 1 plus GS. Okay. So for step input, okay, the signals is 1 over S if 1 volt, okay, and the steady state error is equal to 1 plus Kp, okay, so 1 plus Kp, Kp is the position error constant, and this one is always referred to system type 0, okay. Second one is the unit ramp input. So ramp, okay. The steady state error formula is ESS over 1 over KV, where KV is the velocity error constant. The third one is the parabolic input, okay. Parabolic input is like this, okay, is 1 over S cubic. And the formula is 1 over Ke, which is the acceleration error constant. So all of this we can summarize in one table. Okay, the steady state error from the frequency response for step, for ramp, and for parabolic. Okay, so the steady state formula is given by if step is 1 plus K, 1 over 1 plus Kp, RAM 1 over Kv, and 1 over Ka. Okay, where Kp is the constant, Kv constant, and Ka is constant. And it relates to the type of the system. This one is type 0, no poles at the origin. Type 1, single pole at the origin. type 2 is the double pole at the origin. Okay. So look at this formula. Okay. Look at this formula, and then I will get back to you. Okay. Give me 5 minutes. Is it okay? Give me 5 minutes.
Okay.
Okay, so what do you observe from here? Is there summary for system type 0, ESS, use KP, 1 over 1 plus KP, and find the KP from the open loop transfer function. Second one, if the system is type 1, we use KV, do not use KV. KV. Wrong notation there, please correct. Limit SGS, S to 0. So ESS 1 over KV. And for system type 2, we use KE. Limit S square GS, S to 0, ESS 1 over KA. Please take note the correction. KP, KV, and KA. Understand? Okay? Hello? Hello?
Yes, bro.
Okay. So how to find KP from the book plot? If you have a plot of the magnitude, okay, and the initial plot is 0 decibel slope. Okay, so the initial point here, the dB is 20 log kp. So kp is the constant. Let's say at this point is 10 decibel. So 20 log kp equal to 10 decibel. What is the value of kp, Mukri?
Uh, 3.16.
3.16.
16.
And what is the value of the error?
One over
1.6.
0.24.
0.24. Okay. Understand? So this is a sample of a plot. Okay, it's a type 0. Okay, type 0. And the plot of the book plot, magnitude and phase, open loop. See, the initial condition here is 0 decibel per decade, flat. And what is the initial value here? 16.9. So 20 log kp, 16.9, kp is equal to 7. And the steady state error will be, Wahida?
Yes.
1 over 8.
1 over 8 is 0.125.
Thank you. Then type 1. From the theory, type 1, this is the magnitude plot. Initial slope is minus 20 dB per decade. So what you should do is take a long ruler. Okay, goes to the frequency axis, and that is the value of kV. Okay, velocity, error, constant. So this is sample, S power of 1. kV is equal to 5 radian per second. Okay, which is cut the 0 decibel line. Okay, so 1 over kV. Oh, line dah slow. 1 over 5. 0. Okay. Type 2. Same. This is a magnitude curve, but initial slope is minus 40 dB per decade. So just take a ruler, cut the omega frequency. Okay, then the cutoff here is square root KA. Okay, so in this case, the value here is 3 radian per second. So KA is equal to 9. So the steady state error is 1 over KA. 1 over 9. Berapa? 1 over 9. Safwana?
Oh, 0.111.
0.11. So this is a sample of type 0 and type 1. So type 2 and type 3. Right. So we stop here. Atika, conclusions. Okay, at slide 122. Okay, Atika.
Okay.
So I see you on Wednesday. Okay. Okay, nah? I see you on Wednesday, guys.
Okay, Doctor.
Okay, Prof.
Prof.
Sila baca, please read my notes.